All right, so welcome back. This video is another requested video. This video was requested by Sarah from Dubai, so that's pretty cool. Thank you, Sarah. And in this video, we're going to talk about this two-dimensional proton-proton cozy NMR correlation NMR spectroscopy, and that's really cool. So this is a great little problem. So we've got a cozy NMR here, which we'll talk about. We've also got a normal proton NMR and an IR spectrum, and with all of this information we are supposed to come up with a plausible chemical structure. So that is what we are going to do, and so let's go ahead and get started. So the first thing that we want to do is just sort of get oriented with our cozy NMR here. And what this is sort of the most common type of two-dimensional NMR. There's obviously lots of different types of 2D NMR. This is probably the most common used proton-proton cozy NMR. And what this is telling us, or the information that it's telling us, is it's going to be showing us which signals are coupled to which other signals, basically. So down the diagonal, this diagonal is not really telling us any different information than what we see from our normal proton NMR. Wherever you see a sort of peak or sort of signal on your cozy two-dimensional NMR along the diagonal, those are going to correspond to your peaks on your normal proton NMR. So these peaks here, I should see a corresponding signal on my cozy NMR as well. Now, what is cool about this, or what's sort of unique about a cozy NMR, two-dimensional NMR, is these cross peaks. So when I say cross peaks, basically these peaks that show up not along the diagonal, these are telling us a lot of really awesome, great information. And basically what they're telling us is that these signals are being coupled by, or coupled to, the other signal. So if I look at this signal here at 1.6, for instance, the cross peaks, this peak up here and this peak down here, those are telling me that we're going to that this 1.6 peak is coupled to the peak at 2.4, and it's also coupled to the peak at 0.9. In other words, the protons on 1.6 are splitting the protons from 0.9 and the protons from 2.4. So we can see other couplings here, which we'll talk more about as we go through this and start putting our structure together. But that's the basics of two-dimensional cozy NMR. So let's go back and sort of start from the beginning and look at our proton NMR and start trying to put it together based off of our cozy NMR. We'll sort of go back and forth as we go through this. So the first thing that I'm going to label here is our TMS peak. So right at 0, we've got a signal. That's obviously TMS, so we can just sort of label that and then not have to worry about it anymore. Then I've got 1, 2, 3, 4, 5 distinct signals that I will want to sort of think about and identify. The first thing that really jumps out at me is this big doublet. Anytime we see this something like big doublet type thing, to me, right away, what that's indicating is an isopropyl group. So if I want to have a big doublet, I'm going to need a lot of protons in the same environment that are being split by just one proton. And this is a really common motif to see something like this, where I would have a big signal integrates to 6, split into a doublet by this one proton on this linker. So that's what I would sort of guess is giving us this peak here at about 1.1. And now let's go to our cozy NMR and see what we see for that signal. So here on our cozy NMR, this would be the signal for that 1.1, that really big doublet. And if I look for the cross peaks, there's a cross peak here at 2.5, 2.6-ish. So what that's telling me is that there's a coupling there, and that let's try to get this over here, that this peak here, this doublet, is coupled to this peak out here, this peak way out here, and this then therefore must be this CH group here. Looking at it, it looks like we've got 7 peaks here. It should integrate 1 to 6. So I think that's all those things put together is really telling us that we do have this isopropyl group. That's one of the groups, and then our cozy NMR is really confirming with this peak here that we've got coupling between this peak at, I guess this is like 1.1, and then the peak at 2.5, 2.6. That's what this signal is really telling us. I do want to point out that this is a mirror plane, so when I'm saying this signal, I could also be pointing out this signal here. They're really the same, right? It's the same information. So we just need to sort of identify, one side of this essentially. Okay, so now we have 3 more peaks three more signals that we need to identify. And if we go back to our cozy NMR, if I look at this peak at 1.6, that's one we were looking at earlier, this peak at 1.6, I've got two different cross peaks. I've got this peak and I've got this peak, or we could label that slightly different. I like to just sort of go up and down. That's the way I started doing it. So from this 1.6, I've got a coupling to the peak at about 1, and I've got another coupling to this peak at 2.4. So what that's telling us is that this peak here, let's maybe put in, we'll square these ones to indicate that they are coupling. So I've got coupling here with the circle signal, and then I've got coupling between these three peaks. So this 1.6 peak is coupling to both this triplet here and this triplet over here. Now, at this point, I know sort of what this is telling me. It's telling us we have a propyl group. And the way that I sort of know that is really through experience, I think. But, if we try to break it down, we could say, well, if I see a triplet, we know for sure that we've got a CH2, right? The CH2 is going to be splitting the signal into a triplet. The fact that I have two triplets is really, to me, suggesting that, well, we've probably got two CH2 groups, and then a CH3 at the end. So if I've got a propyl group like this CH3 would be this peak here, because I've got it integrates to 3. It's a little bit bigger than these two, so we can see that. But it should integrate. It should split into a triplet. This peak here, this multiplet, is going to be the central methylene group here. And then this group over here will be my other CH2 that is, again, split into a triplet. And all three of these, right, this 1.6 is coupled here, this 1.6 is coupled here. So we should see that from the cozy NMR as well. So at this point, we can move on to our IR spectrum and see if we can put this all together. This is our IR spectrum, and on our IR spectrum, the first thing that jumps out to me, sp3ch. So this stretch here, below 3,000, clearly, it's very sharply cut off here, below 3,000, sp3 hybridized CH, and then this here is going to be my C double bond O. I can recognize that just by the shape. Sort of, it's got a strong intensity. It's a little bit broad. Broad is really the wrong term there. It's a little bit wider. It's not a sharp peak, I guess. So this is clearly a carbonyl carbon. It comes at about 1710, looks like. So pretty indicative of a ketone. So that's all we're sort of getting from our IR spectrum. So now we can start putting this all together. I know I've got a C double bond O. I know that I've got two sort of distinct pieces, and 1710 is about where a ketone would come. So I might start with something that looks like this. So here is the structure that I would come up with. I've got my isopropyl group over here. I've got my propyl group coming off over here. Let's go ahead and label these. So we'll label A, B, C, D, and E. We know that clearly this is going to be E. Earlier we said that that was coupled to this peak here at 2.5, 2.6. So that's going to be D. Now for A, B, and C, this peak integrates to 3. I can sort of look at that. These look a little bit shorter than this one. This should be A. B is going to be the one in the middle, and then C is going to be here. And that would be my structure, and that would be my assignments. And then we can always go back to our cozy NMR and just double check that the couplings that we're indicating, that those are all making sense. And so maybe we can change these to squares, right? I put those as squares on my other diagram here. And I've got that 1.6 coupled to both of those, and I've got D and E coupled to one another as well. So that's how you would go through this cozy NMR. Hopefully that makes sense. If you've got any questions, definitely let me know. And thanks again for the request, Sarah.